Hello everyone, I am Charlene Mayso among us, and today we're taking a fascinating journey through history where we explore how the greatest scientific minds help us to understand the light, and from the scientific revolution to modern physics. So our topic today is all about the scientific revolution in the 20th century. So we have two objectives. First is describe the contribution of key scientists during the scientific revolution in the 20th century to the study of light and optics. The second one is the explain the principles of light, including wave-particle duality, diffraction, and reflection, based on historical discoveries. So, we start with Nicolaus Copernicus. So, Nicolaus Copernicus in the Third Era Scientific Revolution is his significant contribution on the nature of light, wrote the Revolutionibus Orbium Coelestrum, or on the revolution of the heavenly sphere. So, which contradict the geocentric theory by Ptolemy and proposed the heliocentric theory, and suggesting that the sun is the center of the solar system. So, his model shifted scientific focus to the behavior of light from celestial body, and influencing later optical studies. So, in simple way, he studied the structure of solar system and directly proposed the heliocentric theory, stating that the sun, not the earth, is at the center. So the key point here is he states Nicholas Copernicus state that the sun is the center of the solar system. So let us proceed to the second scientific revolution, is Johannes Kepler. So his significance is studied the planetary motion and argued the eye itself possesses an aperture similar to that of a pinhole camera. So he published his theory of vision in 1604. So in simple means, Johannes Kepler studied how planets move and explained that the eye works like a pinhole camera. So his work helped us to understand, and he explained how the light forms image in the eye, advancing optical science. So his key point, the key point here is he studied the planetary motion and argue that the eye itself possesses an aperture similar to the pinhole camera. So the third one is René Descartes. So his significant contribution on the nature of light, he published Dioptrics, in which he revisits the nature of light and the laws of optics. So he described light as a stick that allows a blind person to discern his environment through touch. Or in simple means, he published Dioptrics, where he explained light as a tool, like a stick of a blind person uses to sense their surroundings, and studied the laws of optics. So he contribute to us to understand light's behavior through refraction and reflection. So the fourth one is Paris de Fermat. So his significant contribution on the nature of light is he suggests that the light rays propagating with a certain speed from one point to another point where they propagate with a different speed would follow to the shortest path possible. So in simple means, he suggests that the light travels in a way that takes the shortest possible time when moving between two points with a different speed. So this is the example of Fermat's principle. So, Fermat's principle is the key to explaining light refraction in optical paths. So let's proceed to the fifth one, Isaac Newton. So, Isaac Newton has four contributions of the nature of light. First is propose that color is property of light and not of the medium through which it propagates. So the second one, discover that sunlight comprises of all existing colors. The third one, design that reflecting telescope using mirrors. And the last one, which is the fourth, advocate the corpuscular theory of light, which suggested that light consists of tiny corpuscles. So his summary is his advance optics by showing that color is property of light, discovering sunlight contains all colors, inventing that the reflecting telescope, and proposing the corpuscular theory, which says light is made of tiny particles. So his discoveries is connected light to color and introduced a particular based on perspective on light. So let us proceed to Christian Huygens. So his significance study is the study of optics through the following contribution. So Christian Huygens has also four contributions of study of optics. First is supported the wave natures of the light in his 1690 publication, Trait de la Lumière, treatise on lights. And the second one, advocate Olaus Romer's theory that the speed of light is finite. The third is argued that light is longitudinal and not transverse. So the fourth is formulated Huygens principle, which suggests that wave propagates from the interference of secondary wavelengths arising from several points on the wave front. So Christian Huygens supported the wave natures of light, confirmed that light has a finite speed, argued it is longitudinal, and developed Huygens principle in explaining how waves spread through secondary wavelengths. So Christian Huygens is his wave theory help everyone us explain diffraction and interference in light behaviors. So the seven in the third era is Augustine Jean Fresnel. Thomas Young rather. So his significant contribution in the nature of light, Young demonstrated the wave natures of light through his double slit experiment. So he published the results in the course of lectures on natural philosophy and the mechanical arts in 1807. So this is the example of double slit experiment of Thomas Young. So the key point here of Thomas theory or Thomas Young contributions of light is he demonstrate the wave nature of light through double slit experiment. So let us proceed to Augustin Jean Fresnel. So his contributions of light, he discovered a series of dark and bright bands appearing behind the diffractor and after passing light through it. So he conducted that bright bands and the shadow arise from the light, and at the edge of the diffractor and the bright bands themselves argue that the light is transverse and obtain the circular polarized light. So the example of Fresnel diffractions is this. So this is the source, a slit, which is the color yellow, and the screen. So these are the source, which is the blue, that reflect to the screen. So that is the example of Augustin Jean Fresnel. So let us proceed to James Clerk Maxwell. So his contributions of the nature of light, he discovered that light is an electromagnetic wave formed through undulations perpendicular related electric and magnetic fields, and formulate an equation for electromagnetic waves proceeding at the speed of light. So this is the example of magnetic wave here, like same with DNA fractions, something like that. So Maxwell equations unified electricity, magnetism, and optics. So it is providing that light is an electromagnetic wave. So here we are at the fourth era, which is the 20th century. So first, Gustav Kirchhoff. So his significant contribution of the nature of light, he is introduced the concept of black body radiation. So a type of radiation emitted by a black body which both absorbs and re-radiates all the energy it contains. So as you can see of the image is Gustav Kirchhoff. He explained, or it is provided at the image that this is the example of black body radiation. So his work is laid the groundwork for quantum theories of light and thermal radiation. So the second, Heinrich Hertz. So his contribution of the nature of light confirmed Maxwell theory on the existence of radio waves. So as you can see in the image above, that he confirmed the Maxwell theory. So that is the Heinrich Hertz contributions of the light. So let us proceed to Wien. His significant contribution of the nature of light, Wien applied thermodynamics and electromagnetic principles to black body radiations and successfully simplified Kirchhoff universal function to a function of one variable. So as a simple means, Wien's law describe how black's body radiating depend on temperature, and it's influencing the quantum theory development. So let us proceed to Max Planck. So Max Planck contributions on the nature of light. Max Planck created a radiation formula that matched black body radiation's spec and its entire range of frequency. Planck introduced the concept of energy quanta, and marking the birth of quantum theory. So let us proceed to the well-known scientist, which is Albert Einstein. So Albert Einstein's contribution of the nature of light. So Albert Einstein revisited the particles theory of light through his propositions of light as photon, and discovered the photoelectric effect. So he considered as the founding figure of quantum mechanics and the special and general theories of relativity calculated calculated the bending of light. So his photon theory showed light has both wave and particle properties crucial to quantum physics. So let us proceed. Albert Michelson and Edward Morley. So his significant contribution on the nature of light, he rejected the idea of the ether, a material that was previously assumed as the main medium through which light propagates. So their work led to understanding that light does not require a medium. So it is supporting Einstein's theory of relativity. So lastly, the last scientist in the fourth era, Paul Adrien Dirac. So his significant contribution of the nature of light is his synthesis the wave and particle nature of light in the quantum theory, arguing that each mode of electromagnetic field could be a simple quantized harmonic oscillator. So Dirac's theory advanced quantum electrodynamics and the understanding of light's dual nature. So and that's all. Thank you. So that's all. That's end our topic today. So goodbye and thank you.